Okay. Hello, everyone. In this lesson, we're going to solve inequalities. An inequality is basically when you have a solution of x that is either less than or greater than something. It's not going to be equal to, because that would be a solution to an equation. Equations don't have inequality signs, okay? So the inequality signs that we're referring to is either less than, greater than, less than or equal to, greater than or equal to. Okay, and in this example, this reads x is less than 5. All right. That means all my solutions for that inequality have to be less than 5, but not including 5, because it's not less than and equal to. There's no line under that inequality sign. Okay. And also, an inequality sign such as this can also be written in a different form called set builder notation. Okay. And actually, this may be misleading. Let me get rid of the arrow. Okay. We can write x is less than 5 in set builder notation. And when you do that, that's going to be translated into this. And I'll break it down for you what it means. Okay. Okay. And basically what that means is that this here reads the set of, and this means all x. This means such that. And then, of course, this part of it is your solution, which we've already discussed, reads x is less than 5, which is this right here. Okay? So you can say the set, which is the braces, okay? These are braces, and that indicates a set, and a set is a collection of objects, right? And the objects that we're referring to in this case would be numbers, right? Solutions for x. You know, if you had a set of baseball cards, then you have a set, and every card is an element of that set or part of that set. So think of this as a collection of numbers, right? And the solution is going to be x is less than 5. So that means for every single value of x, we only want the ones that are less than 5. Okay, we don't want every number from negative infinity to positive infinity. Okay, so that's why we use the braces in mathematics to represent a set of numbers. So you can express that same solution in a more elaborate way using set builder notation. Okay, so I wanted to break that down for you because when we see this later on, you'll know, oh yeah, that's just another way of representing the solution. Okay, so another thing that we want to talk about is compound inequalities, okay? Because when we solve inequalities, occasionally you'll get more than one solution. You get two solutions. Or you can have two inequalities together. And when you solve both of them simultaneously, you're going to get two solutions on the graph. And sometimes they overlap each other or intersect, or sometimes they branch out and never meet each other. And we need to know the difference of how that occurs, right? Because, you know, these solutions on the graph, okay, when you graph them, and if there's like a gap or a space, then it means those values can't be chosen for that inequality. You'll get a false statement when you check it. So let's say you had, x plus 4 is less than 1, and then you had x plus 2 is less than 3. Okay, now, and let's say I write the word and, okay? all right? So I have two inequalities. So when you see the word and, then it's a compound inequality. Also, you can use the word or, but that's a different situation. I'll explain that in a minute. Okay? So if you go ahead and solve these, it's just like solving equations. We're going to do its opposite function. And you want to do that because the 4's will cancel. Your goal is to isolate x on the left side. I like to get x on the left side, so when I read the inequality, I start with my variable, followed by my inequality sign, followed by my numerical. Okay? You can also read it backwards. It can also be written backwards, and I'll show you how to do that in the next slide too as well. For right now, we're just going to solve two basic inequalities. 1 minus 4. 1 minus 4, what is that, minus 3? And then here, so that's one of my solutions, okay? And the other one is we're going to subtract 2 on both sides, and then the 2's cancel, and you're left with x is greater than 3 minus 2 is 1. That's your other solution. 3 minus 2 is 1, okay? So, let me make sure this is correct. You know what? Hold on, me. Okay. So I solved both inequalities. I got x is less than 1, okay? And, you know, just to make sure everybody knows that I replaced the inequality sign with x plus 2 is less than 3, not greater than 3. So I got x is less than 1, and now I'm going to graph it, all right? And what we want to do is less than negative 3. Well, that is going to be a parenthesis. Okay, and less than 1 is also going to be a parenthesis. Okay, so let me go back and explain that when you have inequalities, okay, it's really important that we know this. Okay, so before I graph this, let's pause for a minute and let's look at the signs. When you have less than or greater than, we can use open circles, which basically looks like this. Okay? Or parentheses. And if we have less than or equal to, you know, with the line under it, then we can use what we call closed circles or brackets. Closed circles means it's shaded in. So let me do both here, okay? So that way you can see it and you can compare it. Okay, if you wanted to use an open circle, remember less than associates with an open circle, so you can put it there, all right? And anything less than negative 3 is going to be shaded to the left, and that goes to negative infinity. You need to indicate the direction it's going. So since the arrow is pointing towards the left forever and ever and ever, we can donate that with a negative infinity sign. And same goes for the other value, okay? So if and I want to put these on separate graphs so you can see what happens. All right, 1, again, less than is an open circle. So I'm going to put an open circle over 1. And anything less than that is going to be shaded to the left as well. And that's also in the negative infinity direction. Does that make sense? Okay. So when we do this, okay, if we were to graph these, okay, all right, if we were to graph these on the same graph, all right, you notice that the graph starts at 1 and goes all the way to infinity. The other graph starts at negative 3 and goes all the way to infinity. So if I superimpose these onto one graph, then I can just go ahead and put my open circle over 1, and then just shade everything to the left to negative infinity. Okay? And now, my solution set. Now, here's what you got to be careful. You would say, okay, I have my graph, so I'm all set. That means all my solutions have to be less than 1 to infinity. I'm going to stop you right there because you would be incorrect. Remember the key word, and. And when we have the word and, we want to know where they overlap. Okay? So the graphs are going to overlap right here. This is where they overlap. They start overlapping each other from negative 3 onward. Okay? And everything before that, we can discard. We don't want anything greater than negative 3. Okay? So if I superimpose both of these graphs, then both graphs, okay, really start to overlap from negative 3 onward. And that is my true solution. So we can go ahead and just literally not worry about all of this, okay? We want to know where they overlap, and they overlap right over here. Okay, this is where they overlap. All right? They start to overlap when the graph catches up to negative 3, and then see negative 3, and then from negative 3 onward to negative infinity is where they overlap each other. Okay? And that's what you want. Okay? So that is my true solution when x is less than negative 3 to all the way to negative infinity. Okay? As a matter of fact, if you were to do the interval notation for this, okay, the interval notation is going to look just like the graph. It's going to be from negative infinity, comma, to negative 3. Since we used an open circle, we can use a parenthesis because we're not allowed to use circles in interval notation. All right, and you write it as a coordinate, almost like as a coordinate. And then we always put parentheses around infinities. So that's a rule. So we always use parentheses around negative infinity and positive infinity. Okay, that's just something you have to memorize. Okay, now going to the next slide, if I take that same solution, right, if I have, x is less than negative 3, and the other solution was x is less than 1, right? Remember we just solved it on the previous slide? You can also use, if you don't want to use the circles, you can use the parentheses, okay, which I highly recommend because it'll be easier if you use the parentheses. So let's go ahead and graph these. We'll review it, okay? So here's 0. Here's 1, and then here's negative 3. So less than negative 3 is associated with a parenthesis. So I'm going to curve it to the left because less than means I'm shading everything to the left to negative infinity. And remember we graphed it again, right? 0, 1, negative 3. All right, 1 is here. So less than 1 is also going to be a parenthesis, and that's also going to be curved to the left to negative infinity. And as I said in the previous slide, when you graph this onto one graph, right, here's 1, here's negative 3. Okay, remember that this first graph is x is less than negative 3. The second one is x is less than 1. And then the third graph is when they're together. Okay, so you got to remember that if you look, this is where they overlap. because the original problem read and, I forgot to put the word and, x is less than 3 and x is less than 1. When you see the word and, that's a compound inequality. And in that situation, we want to know where both solutions have in common, or where they overlap or intersect. That's called an intersection. Okay? So this is called an intersection. Oops, sorry, it's hard to write with these sometimes. Let me go ahead and intersection. All right? And that's where they overlap. That's what we're interested in. So when we put it on the final graph, we care about everything from -3 to -infinity. Okay? So we're going to put a parenthesis and we're going to face that to the left. And that would be our final graph. So our final solution is, all my solutions are less than -3 to -infinity. Now, if you were to write this in interval notation, okay, then we read the quantities from left to right. So we're starting off with the -infinity, comma, to -3. But you notice that we use the parenthesis around the -3. And that's why I like to use it when I graph it. So when I do the interval notation, it's an easy transition. And it's almost as if I'm writing a coordinate, right? Like an ordered pair. And that's how you want the interval notation to be like. And then we're going to use parentheses around infinities. So the key thing is here, we always use parentheses around -infinity or +infinity. Okay, so I'll just kind of reiterate that like I did on the previous slide. And that would be your interval notation. Okay, so let's do another example. Okay, and let's see what we get. And before we do anything, let's solve them. So here we're going to divide by 2, because 2 times x, that's multiplication. The opposite of multiplication is division. When we divide by the coefficient of 2, whatever that coefficient is, so it cancels, then you're just left with x is greater than and equal to 8 divided by 2 is 4. That's clearly one of my solutions. And then we're going to solve the other one. Again, we're going to isolate x. I like to get x on the left side, so when I read the inequality, I read it from left to right. I'm going to add 1 to both sides. Okay, and that's going to give you with 2x, 1's cancel, less than and equal to 6. And then now go ahead and divide both sides by 2. So 2's cancel, and then you're just left with x is less than and equal to 3. That is my other solution. And we can go ahead and graph them and see what happens. All right, so let's start with the first one. That's going to be 4. Okay. Anything greater than and equal to 4 is going to be a parenthesis, a bracket rather. Remember, bracket. Greater than and equal to 4 means we're shading to the right, and we're going to put +infinity. That's the direction it's going. This reads 4. Okay. If we graph the other one, 3 is going to go a little bit less than 4. Well, anything less than and equal to 3 is also a bracket, but less than is going to be in this direction to the left. And that's going to be -infinity. Okay. And if I superimpose these onto one graph, okay, so 3 goes here, 4 goes there. You notice that the graph, this one was going to the right, to +infinity. This one was, with the 3, was going to the left, to -infinity. All right. And you notice that there's a gap here. There's no solutions there. So when I superimpose the graphs onto one graph, right, I have a gap. And there's a contradiction, okay? This original problem was and, by the way. It read 2x is greater than or equal to 8 and 2x minus 1 is less than or equal to 5. I should have wrote that earlier, but that was the original problem. It had an and. And when we have an and, the graphs should overlap. There should be an intersection, but there isn't. This is a gap. This contradicts it. So this right here contradicts this. And therefore, there is no solution. After all that work, there's no solution. Well, that can happen because of the contradiction. So don't be surprised if that can happen to you. If this were to be or, then it would be okay. And I'll explain what or is in just a moment. Okay? So that's something to keep in mind. All right? All right, let's do another example. Go to the next slide. Okay? And we will have another inequality. Let's do a compound inequality. And if you have a compound inequality, that means we're going to solve it at the same time. Whoops. Let me write that better. Let me write that. Okay, so compound inequality means you have more than one. You have two. Okay, so again, you notice the x is in the middle. We have one inequality to the left of that x and then one to the right. So we want to get the x in the middle isolated. And in order to do that, we can start subtracting the 5 so that it cancels. But you got to do that to the right of the inequality sign, and you also got to do it to the left, to the other one simultaneously. Okay? So to keep things balanced, all right? You have to be able to subtract or add on both sides of those inequality signs. Okay, so we're going to rewrite that. 1 minus 5 is minus 4. This leaves you with x. 3 minus 5 is minus 2. Okay. And then this is one of my inequality signs. X is less than negative 2. The other one is here. That's written backwards. All right, so in order to write it, you can just switch out the x and the negative 4, but then whatever this inequality is, we're going to reverse it. And then now you can read it from left to right. It's okay to read it from right to left as long as you know that it reads x is greater than negative 4. But if that's confusing, then rewrite it like I showed you here, and then you'll be able to say, okay, x is greater than negative 4. But you've got to flip the inequality sign to compensate the switch of the x and the negative 4. So you've got to switch everything. And now you can go ahead and graph these, and you should get your what it would look like. So you graph it. Okay, negative 4 is going to be here. Negative 2 is going to be there. All right. And if you remember from the chart before, if you have less than less than negative 2, less than negative 2 is going to be a parenthesis, and it's going to face to the left. And then we're going to shade everything up till negative 4, but let's read negative 4. X is greater than negative 4. Greater than is a parenthesis facing to the right, and the graphs overlap. So when they overlap, that is an and. Okay, that means there's an and here. Okay? And that's what the graph would look like. You care about where they overlap, not if you graph them individually, yeah, they're going to go on forever and ever, all right, in both directions, but we don't want that. We want to know where they overlap, what they have in common, okay? So in order to, realize that, is that, if I break it down into separate graphs, right? Let's do the -2. Well, we said everything less than -2 is this way, right? And then if you do the other graph, and put -4. Okay, well, -4 is greater than -4 is a parenthesis going in this direction. So yeah, if you graph them separately, then they would continue in the infinity directions. But look what happens in between -4 and 2. Okay, so if I put -2 here, look what happens. They're going to overlap in between this interval. Do you see that? They're going to overlap. Okay, and that's why you put the overlap here. So you can almost kind of like see that, see where they overlap. So if you put it on one graph, that's where they overlap. And hence, that's why we just want the intersection between -4 and -2. Okay, if you want the interval notation, then it should just look like the graph, okay? We have parenthesis, and then we start -4, and then comma, -2, parenthesis. You notice the graph and is going to look just like the interval notation. That's why if you use the parentheses or the brackets, you can almost kind of see what the interval notation will look like. Okay? So it's very similar here. Can you kind of see it? The -4 has the parenthesis, and the -2 has the parenthesis. So you just write it as a ordered pair, and then you have it. Okay? So that would be the solution for that. All right? And okay, so let's do another one. Okay? And we can go ahead and do another one where we have 6 is less than 4x plus 2 whole over 3 is less than 10. All right, so our goal is to get x isolated. We have a lot of algebra to do to get that isolated. So the first thing I'm going to do is I'm going to eliminate the fraction, and I'm going to do that by multiplying. Let me just rewrite it here with a little more room. Okay. So here is 10, and this is 6. So what I'm going to do is this is 4x plus 2 divided by 3. The opposite of division is multiplication. And I do that so that the 3's will cancel. But I need to times it by 3 to the right of the inequality and also to the left of this inequality. I have to do it 3 times. So when I do that, 3 times 6 is 18. And then since the 3's cancel, I'm just left with 4x plus 2. 10 times 3 is 30. Okay? And then I go ahead and solve for x. Let's move the 2. Let's get rid of the 2 by subtracting it. And we're going to do that on both sides of the inequalities. One to the right, one in the middle, and one on the left. The one in the middle is going to cancel. And then you're just left with, what is this, 16? 4x, and that's 28. And then the last thing is in the 4 times x, so the opposite of multiply is divide. So we're going to divide everything by 4. All right, coefficients of 4 cancel. 16 divided by 4 is 4. This just leaves me with x, and that's just going to be 7. So now you have your solution. You have x is less than 7, and then you have this one, which is backwards. So if you want to rewrite it, switch the x and the 4, and then reverse the inequality, and now you have x is greater than 4. Okay, so go ahead and put that on the number line. So we're going to put 4 here, and then we're going to put 7 over here, okay? And if you read it, x is greater than 4. Greater than 4 is a parenthesis, and that's going to be curving to the right. And then it's going to go to the right, We'll stop at 7, read the inequality. X is less than 7. Less than is a parenthesis facing towards the left. Here we go. That is an overlap. So that tells me that this is an and. Okay, so this is an and. They overlap. And if you want to do the interval notation, then your interval notation should look just like the graph. Parentheses around the 4, comma, 7, and then we put the parentheses around the 7, and there you have it. Okay? That is what we call an intersection. Okay? Now, there's another situation that can occur with the word or. So you can have a compound inequality with the word or. Okay? And the or donates a union. And we use a capital U for that. And the union of the graphs, okay, is basically where the solution set is not going to exist. There's going to be a space or a gap, okay? So let's have an example. We have 7x minus 5 less than and equal to 6, or x plus 2 is greater than or equal to 5. So we have two inequalities. It's a compound inequality, except we have the word or. And let's go ahead and solve these individually. So we're going to isolate the x. So we're going to put plus 5. So this cancels, and you're just left with 7x less than 1. I'm sorry, not 1, 11. Okay? And then we divide both sides by 7, so the 7's cancel. Then you just have less than and equal to 11 over 7. Okay? And that's one of my solutions. So, and then here we're going to subtract 2. So that cancels. Then you're just left with x is greater than 5 minus 2 is 3. That is your other solution. And now we're going to graph these, okay? I like these because I don't have to write separate graphs, and you'll see what I mean. First of all, 11 over 7, okay? 11 over 7 is 1.5, okay? So if I use 0 as a reference point, let me go ahead and make that a better 0. Okay, 0. So we have 3 is going to be over here, and 1.5 or 11 over 7 is going to be before that. So when you do the graph, just write the original fraction, okay? And we know 1.5 is less than 3. So when we do less than and equal to 3, less than and equal to 3 correlates to a bracket, and less than and equal to is in this direction, okay? Whoops. Sorry about that. Hands get slippery here. And that's negative infinity. Greater than and equal to 3, greater than and equal to is also a bracket, but greater than is this direction. And that goes in the positive infinity direction. So indicate your infinities so you know what direction it is, because you're going to need that for the interval notation anyway. And you notice that there's a gap. So we call that a union. And that tells us that there's no solutions in between 11 over 7 and 3, or 1.5 and 3. Okay? So like 1.6 would not be a solution, and 2.9 would not be a solution, and anything in between there. So when you do the interval notation, you have to indicate that gap or that union. All right? And like I said earlier, you just use the U, okay, the capital U. So when we do interval notation, always start from your left, right? Negative infinity, comma, 11 over 7. And what did we put around the negative infinity? Okay, what did we put around the negative infinity? We always put parentheses. And since the inequality for 11 over 7 is less than and equal to, we're going to use a bracket. The union, use a capital U, and then the graph picks up, again, bracket 3, because remember, we're including 3. Greater than and equal to is a bracket, so we're going to include 3, comma, infinity. Okay? And that's it. Infinity, sorry. And that's your interval notation for that one. Okay? Let's do one more. And let's do another OR. So x is minus 7. X minus 7 less than negative 5, or negative x minus 1 is less than 0. So we're going to solve these, okay? So let's start with the left one. We're going to add 7 to both sides so that these cancel. Negative 5 plus 7 is 2. Okay? So x is greater than 2 is one of my solutions. Okay? You notice we have the word or. Okay. So let's go back to that now. We're going to add 1. So these cancel. Then you're just left with minus x is less than 0 plus 1 is 1. And now you have that solution. Actually, I need to, before I officially box it, I'm not finished yet. That was negative x less than 1. We can't have negative x solutions, so we're going to have to divide by that invisible 1. Okay, so the negatives cancel, and then you're just left with x is negative 1 here. But then when we divide by a negative, the signs are going to change on both sides. So to compensate for that, we're going to flip the inequality sign. Remember, 2 negatives on the left now become a positive, and then a positive and a negative on the right of the inequality become a negative. So those 2 signs originally changed. So we need to compensate for that inequality and flip it so it's facing the greater side, the positive side. Okay? So think about it like it was originally negative right here and originally positive here. But when I divided it by that minus 1, the sign now became positive here and negative here. So the reversal of those signs, you need to reverse the inequality. So this is my official answer. Okay? X is greater than negative 1. So when we graph that, okay, negative 1 is here, and 2 is going to be to the right of 0. Well, anything less than 2 is going to be a parenthesis, so it should be in this direction. Okay? All right. And so it's going to go this way. Okay. And anything a little greater than 1 is a parenthesis. Actually, let's do it separately because I want you to see something first. So let's do that. Negative infinity. Anything less than 2 is going in that direction. So now we'll do the same graph. 0 and negative 1. Okay. And anything greater than negative 1 is a parenthesis. And we're shading everything towards the right, to positive infinity. But if I do this on one graph, okay, so when we put these on one graph, you got negative infinity to a positive infinity. So if you break this up by graph, I do the first one. The interval notation for the first one is negative infinity, comma, 2. And then the interval notation for the second graph is parenthesis -1 to positive infinity. Okay, since they're splitting off in separate directions, they're kind of overlapping, but remember that when you have an OR, the graphs are going to go in opposite directions, but at the same time, if you put them on one graph, it's going to cover every solution on the x-axis. So the final notation is -infinity, infinity. Okay, it's going to be all real numbers. Okay? Alright, I hope that this video was very helpful, and I know it's kind of long, but it has quite a few examples that you can compare to, different situations that will come up with inequalities, and I hope that this covered quite a bit of it. I'm looking forward to the next video. You have a great day.